completely clear definitions about their rules, their tasks, what they should do, what they need. Okay, we should prepare this information to other parties to make this structure, this complex structure, clearly for other parties, for the rest of parties, rest of peoples, I don't know, rest of systems. For example, I want to travel to Baghdad. Okay, I bought it. I bought an airplane ticket. I want to travel to Baghdad. First, I should purchase the ticket. Then I should go to the airport. They check my ticket, and then uh, I'm passing some gates, running toward the airplane, and then the airplane goes toward the band, and then it takes off uh, toward the Iraq. Okay, when the airplane arrives to Baghdad, it's landing on Baghdad airport and stopping in some areas. I should leave the airplane and goes through the gates, uh, catch my bags, and finally they check my ticket, and uh, after that I can leave the airport. Look at this series of events. I'm starting with buying a ticket, purchasing a ticket, and finally, if I haven't have a complaint, I should bring my ticket to them and say, okay, for example, something wrong happens with my ticket in my travel. I don't know, but I should uh, bring the ticket to them and say, okay, I have a comply about, for example, behavior of uh, different peoples in the airplane. I don't know. Okay. If I look on these steps, looking on these steps for traveling from a source to a destination, here an airplane brings me to Baghdad. Just I should prepare some preliminaries and then go into an airplane. The airplane will bring me to Baghdad airport. Okay. Each of these steps, we have specific roles, specific tasks, specific jobs to do. Firstly, I have to buy a ticket. When I'm going to the airport, I have to bring my baggage, my luggage for checking. Then I should pass the gates. You know, I'm passing through all of these steps one by one toward the airplane, and then the airplane will take off. It brings me to Baghdad, and then again I'm passing all of these steps one by one. This is a system for an air launch and for an air traveler, air travel. Okay. And now we can put these steps into a more clear steps or into some layers. And you can see here those layers with similar names have similar activities. For example, when I'm run away to take off, or run away for landing, or when I'm going through the gates, past the gates, it's a gate service, and I should do similar things, something similar to the source happens in the destination. In this slide, we can see that those complex system is presented in a layered form in some layers. So my service, I can receive this service, and to receive it, I should pass through these layers to the other side. So in all of complex systems, we are going toward defining a layering structure. Why? Why we use a layering structure to describe, to discuss, to design a complex system? Why? Because when we are using a layering technique, it can make data structure explicitly, can make it explicit. For example, if I look on a layered system, I can find the relationships easily, very easily. The relationship between different parts. Especially when I use a layered reference model. I'm creating a layered reference model, and then I'm applying that model into my system. The reference model is completely clear, and then I'm using it. I'm using it, I'm applying the strategy on my system. Also, when we use a layering strategy, it means that I'm creating some modules in my system. And for example, when I want to maintain the data structure, or when I want to update that complex system, it's very easy for me, because just I need to focus on a specific part, a specific module, a specific layer of network, and just work with it. It means that even if I want to change it completely, change a part in my system completely, I don't need to change the whole system. Just I need to change a specific part of the system according to the reference model. Just I need to take a small portion of that. So a computer network as a concept, today's computer network, we accept a model, its name is TCP IP model. Okay, or Internet Protocol Stack. There's no difference between them. In this slide, slide 71, you can see the structure of Internet Protocol Stack. It's a layered stack with 5 layers. From the bottom, the layers are physical link, network, transport, and application. Let me talk about each of these layers shortly. Okay. At the bottom, starting from the bottom, the first layer is physical layer. At this layer, we can only send information. Those information are sent as a signal in the form of a bit or byte. Yes, Naina. I'm recording all of the sessions. Don't worry. Always I'm recording the sessions. Okay? Don't worry about them. So in physical layer, we only have some bits and bytes and some signals. I don't know if I look on the signals in physical layer, I don't know what's that. Just there are some signals. I don't know what's that. Okay, and I can understand them. The next layer is link layer. The link layer is responsible to send data from one neighbor to another neighbor. Transferring data between neighbors. Okay. For example, when I'm talking about Ethernet, when I'm talking about Wi-Fi, or point-to-point protocols, or Bluetooth or something like that. Okay. Parts of those names are related to the physical layer, but most of the topics, the discussion is about their link layer. Now you can see that the physical and link layers are completely together, related together. So sometimes some people say that, okay, the Internet Protocol Stack has 4 layers. Instead of saying it has 5 layers, some people say that no, it has 4 layers. Why? Because physical layer and link layer are completely related together, have a strong correlation. It means that if I make changes in the physical layer, its link layer will be changed too. It must be changed too. Okay, it must be changed. So some people say that okay, physical and link layer should be combined into a single layer. They call it file layer. File or physical layer. So if someone say that okay, the internet protocol stack has 4 layers, we say yes, that's correct. And if someone say no, it has 5 layers, again we say okay, that's correct too. Why? Because the first ones combine the link and physical layer and layers, and the second one separate those layers from each other. Okay. The third layer is network layer. Network layer is responsible to send information from the source to destination. It must find a path and forward the packet through the destination. Look at this. In layer 2, we are care about the information, sending information between one neighbor to another neighbor. But in network layer, we want to send information from a source computer toward a destination computer. They are far from each other. So their site, their view are completely different. The link layer just see the communication between two neighbors. One system to its neighbor, one to one. And in network layer, one system should think about the far distance destination and say that okay, if you want to go to that destination, you have to go through this path. So the network layer is completely different from the link layer. The IP and routing protocols are standing here. The fourth one is transport layer. Transport layer responsible for sending information between two processes. A process in the source and another process in destination. Transport layer should send information between those layers. Who determines the forwarding of network? The forwarding process is applied in the network layer. The network layer should find a path between the source and destination and then forward information toward the network, toward the destination. Okay? But in transport, we are talking about two processes, one in the source and the other in the destination. Two processes decided to communicate together. Again, two processes, one in the source and the other in the destination. They want to communicate together. So they are not care about the network structure. In link, we should be care about the network elements one by one. In routing, we should be care about the network end to end. But when the network elements works in layer 3, they act, they think end to end, but they act hop by hop, step by step. But in transport layer, we are talking about sending information between two processes, one in the source and the other in the destination. So in layer 4 or in the transport layer, we are not care about the network, just we are care about the source process and destination process. Let us ask me, who is responsible for loss? It depends. All of these layers can be responsible. For example, when I'm talking about the link layer, I say that, okay, the link layer is responsible for sending information between two neighbors. So it's responsible for loss between two neighbors. When we talk about networking, we know that each packet should be checked on each router. We should check each packet completely. Okay. When we talk about transport, in transport layer, we have two main protocols, TCP and UDP. TCP is care about packet loss, and even it's care about packet reordering. The last layer is application layer. It's care about the loss again. Okay, and even when we are talking about physical layer, it's responsible too. For example, when we send information over a wireless medium, we have several techniques to be clear about the packet errors, the frame errors, and frame loss. All of those layers are responsible. Each of them is responsible in its area. Okay, what is the application? You are watching on your screen, your laptop screen, your cell phone screen, your computer screen, and what you say is the application layer. So application layer is something that I can see it. It's something running on my computer, nothing more. But when I want to communicate with another application over the internet, I need to run an application. When it runs, the operating system will assign a process to that application. When we run an application, the operating system creates a process for that application. And that process is responsible for network communication. My application is not important. For example, my data is encrypted, or it's plain text. It's not important for my network. That is something interesting for the application layer, not for network. The network never knows about the sended information. Never. Just someone say, okay, this is my message, send it to someone else. Okay? And the network will try to send it. The network never understands what they are sending. Never. So when we talk about computer networks, most of the time we can see that experts never talk about applications. Mostly they talk about the lower layers. Although the application layer is very important, but it's not too related to computer networks. Mostly the first lower layer are important for us. Okay. What will happen in reality? Look at this slide. There is one source and one destination. Okay? One computer and, for example, a university server, Adobe Connect server in university. Okay? And my computer start to send a message to the server. For example, I'm talking right now. My computer, my laptop captures my voice, make a message, and it tries to send this message to the server, the Adobe Connect server. Okay. So the application layer create that message. It sends it to transport layer. In transport layer, this layer adds a header to the message. In other words, it encapsulates the message into a new structure. We call it a segment. A segment is a structure in layer 4. The message comes from layer 5, is put or is encapsulated into a segment. And this segment has a header. Okay. Then layer 4 passes this segment into layer 3. Again, a network layer or layer 3, again the segment is encapsulated into a datagram or into a packet. Okay, so each segment is encapsulated into a datagram. Then that datagram is passed to layer 2. Again, in layer 2, the data is encapsulated into another structure. We call it frame. The data is encapsulated. The datagram is encapsulated into a frame. And after that, this frame is sent through the physical layer toward the destination. Something like this. Look at this. A message comes. It is encapsulated into a segment in layer 4, encapsulated into a datagram in layer 3, encapsulated into a frame in layer 2, in the source, and then this packet, this information is sent through the network. And at the destination, we can see that one by one, those headers, those information controllers, one by one are removed, and the rest of information are passed toward upper layers. Maybe someone asks me, okay, what are those headers? Those headers are contains specific information about the packet. For example, how can I define that a message is for me? In layer 3, we can add some information, and destination can check it. That is easy. So a computer network is a layered system. It's a layered system with some specific headers added to the message of the user. Those header contains control information related to the roles at each layer. I know that those information, those headers are waste. I know those information from my side. I'm an end user. From my side, those control information, those headers are redundant and they are wasting my bandwidth. Okay, but those layers need the information. They need their headers information. So when we try to send information, we spend more bandwidth because of the headers. Okay, Look at this slide. This slide shows 4 different elements in a computer network: source, destination, switch, and routers. You can extend this picture to bigger areas, to bigger networks, but the basic topic is the same. When a source tries to send information, it sends a message. This message is encapsulated as a segment, then in a datagram, and then in a frame. And after that, we send that frame over the physical link. If those messages arrives to a switch is a layer 2 device. So here you can see that sended information are passing from layer 1 to layer 2 to make it clear. Or for example here, in a router is a layer 3 tool. So it sends information to its layer 3 or its network layer. Okay. In switch and router, we can see that only 2 or 3 layers are presented. Why? Because we don't need more layers. In their application, they don't need them. But at the destination, again, we can see that the arrived frame is passed one by one toward the upper layer, toward the application layer. And the sended message is received to the destination. Here you can see that if I pass through the layers, I should check and I should change some information. For example, a switch does not change it, does not change in a frame, but a router will change the information. So again, the router should define it. Okay. The last part of this chapter is about history. You should learn the basics. If I ask basic question and you learn basics, you can draw something like this very easily. Okay. The last part of this chapter is a history of internet. You can read it yourself. I don't want to teach a story. You can read it if you want. Okay. So the chapter 1 is finished at the moment. And next 2 weeks, I will take an exam from you from chapter 1. In Iraq, today is 24th of Safar. Our exam would be the 9th of Rabi al-Awwal. Or in Iran, today is 10 May, 10 of May, and our exam would be on 24th, 24 May or May. Or today is October 2nd, and our exam would be on October 16. So please read the content of chapter 1 completely clear. Okay. Is there any question about the content of chapter 1? Any question? Okay. Let me stop these slides, and share my screen. Have you any question, Naima? Yes, I will write. I will write about the exam. Okay, TDM or FDM, which one gives more guarantee? Both of them, Naima. For example, when I'm talking about the TV channels or radio channels, you can see uh, your radio or your TV just change the uh, frequency range of um, channels. If we want to uh, see or hear a voice of a radio channel, just we need to change it. But one more, uh, but this is important that mostly TDM is used for digital content and FDM is used for TDM for digital, FDM for analog uh, systems. So in today's systems, when we talk about digital systems mostly use TDM. Sometimes, for example, in cell phones, sometimes we have a combination of TDM and FDM in some technologies. They create some channels using FDM, and then that FDM is divided into some time slots as TDM do. Okay, so both of them can guarantee, but in digital systems, TDM is better than FDM. Okay, wait a moment, please. I will return. Just wait a minute. Uh, I will write about the exam, but now I want to talk about uh, network analyzer tool. Its name is Wireshark. Okay, I will talk about it, and then I will give you a homework. You should complete it in 1 week. I will write about the homework too. Okay, but let me share my screen. Okay. Okay. This is let me close this one. Oh. You should run Wireshark as an administrator. What is Wireshark? Wireshark is a network analyzer, is a network traffic analyzer. Wireshark tried to capture different frames, all the frames from the network platform. In reality, your computer will receive all the frame from the network, the whole frame. But the system checks the destination address, and if the destination address is equals to its destination, its address, then it will pass the frame, the captured frame, into the upper layers. Otherwise, it will drop the frame. But the network analyzer tools, traffic analyzer tools, can make a copy before dropping. Your network card captures the packet. The network traffic analyzer make a copy of that packet before dropping it. Okay, to analyze the behavior of network. Here, when you start Wireshark, you can see here a list of different connections. Here, these items are my network connections. Here you can see currently I'm connecting to the internet using a cable, a copper cable. So here you can see it as an Ethernet technology. And here you can see the behavior of my network from the send or receive point of view. Okay, you can see it changes during the time, but rest of network adapters doesn't work currently. There are two other adapters too. One of them is npcap lookup adapter, and the other is lookup traffic capturing. These two items are related to Wireshark, so I don't want to be cared about them. Let me start with my Ethernet traffic. I'm choosing it and double click it. Here, in the top side of this window, you can see the whole traffic. coming or sending, coming into or sending from my network card, my Ethernet network card. Okay, you can see different information. For example, the time of that information, the source address, destination address, its type, its packet length in byte, and other information. Okay, let me stop this one. Okay, here you can see my Wireshark just too many packets. I can arrange everything. For example, I can arrange based on protocol types, something like this. Look at this. All of these packets are RTMP. Then SSDP, SDP, TCP, I don't know. And here in the bottom, you can see another window. For example, let me choose this packet here. It's 9. Here, you can see its protocol type is TCP. So, in this window, you can find all of information in header of frame, header of IP, and header of TCP. You can see all of them. We talked about headers, and here you can see those information. Okay, and if you are interested about the contents in, for example, hexadecimal format or in octet, you can see something like this. So easily you can find lots of information. Even here, let me check. No. Here, if I had an HTTP request, you can find the whole information about that HTTP request completely with the whole properties, whole features. Here. So that is simple. If you want to hack, for example, hack a wireless network, just simply you can run the Wireshark near to the wireless antenna and capture the messages. Simply you can hack lots of accounts. Wireshark knows more than 7,000 protocols. So it's a powerful tool. Okay, what can I do as a network administrator? What can I do with these tools? For example, I want to receive some statistics about my network. For example, I want to receive some statistics about the length of packets in my network. Here we have a length field here, but in statistics I can find it easily. Statistics menu, and then we select packet length. Look at this. In my network, all of the packet has minimum length of this information. If I look on this information, you can see near 1/3 of this information, this packet, has length between 60 to 79 bytes, and the bigger group is packets with length of 1218-2779. Okay, this is one of the most important um, statistics. You can see several other things. For example, you can draw the IO graph. You can plot the behavior of your network, for example. Let me enable this one. Okay, this is a plot of received traffic from different source of networks in, for example, 1 second here in the bottom. If I change it into 10 seconds or millihundred second, 1 millihundred. Okay, even I can find different TCP errors. You can change the colors whenever you want. Okay, you can either in this button you can write some filters here in this cutter, or use another for example flux graph. For example, this is a flux graph of different traffic sites. Okay, so you can do many things. For example, if you are an administrator, you can use telephony menu. It knows most of uh, main protocols in telephony, in IP telephony networks. If you are using wireless, you can find information about those wireless using wireless menu. So please work with these tools. It's very simple, but it's very powerful. I had in the past, I had some students who work with these tools and hack other accounts, because these tools present the whole information uh, about the content traversing across the network. Okay, please work with this application. Those students just capture information and look on the content of those information, nothing more. Uh, read the documents, work with it. Okay, and I will upload uh, a new and the first homework for you in a few days, and you must do it yourself. Please don't copy your reports. Please don't copy your reports. Okay. Yes, hello Hassan. Yes, you can find it easily and find um, just search for Wireshark. That is free, simple but powerful. Mhm. Even you can save your capture information. If you want to exit from Wireshark, it will ask you, okay, do you want to save the results uh, or yes or no? You can handle some settings in Wireshark to capture your information. Those information is useful for different types of attacks, for example, or talking about the status of network traffic. Okay, that is enough for today. I will prepare more details about the homework and the exam for you in a few days. Is there any question? Okay, I wish the best for you during this day, and the rest of days in this week. Um, Good afternoon and goodbye.